students, in this video we will find the solution to the case study questions that are launched by the CBSE for the academic year 2020-21 in class 10th mathematics. This question that you see on the screen belongs to chapter 6 triangles of 10th CBSE mathematics, and case study question about it. There will be a case or a paragraph or a situation that will be given. Based on this situation, there will be 5 MCQs that will be following this situation. A student is supposed to answer any 4 out of the 5 questions, and each MCQ carries half a mark. So the maximum marks for a case study question is the 2 marks. Now let us read the case study that is given. This belongs to the triangles chapter. So it states a case study based to question number 18 of the standard mathematics sample paper that is released this year. So standard question paper this belongs to. So it writes scale factor and similarity. So about scale factor, a passage is written below. A scale drawing of an object is the same shape as the object. Scale drawing of an object is the same shape as the object but of a different size. Next it says the scale of a drawing is a comparison of length used on a drawing to the length it represents. That means the length in a drawing divided by length actually it is having. That ratio, comparison means a ratio, is called scale drawing. Like we have a small like a world map. World map is a scale drawing of the real world landmass. Now it writes scale is written as a ratio, and this is the reason why it belongs to similar triangle chapter. Why? Because similarity condition is what? If 2 triangles are similar, then the corresponding sides remain in the same ratio. Corresponding sides are proportional. They come in scale, they come in same ratio or proportional. That means similar triangles are drawn on scale factor. Now it writes next similar figures. I'm underlining while reading. Similar figures. What is the meaning of similar figures? The ratio of 2 corresponding sides in similar figures is a scale factor. That means if we have 2 triangles, the corresponding sides will be in the same ratio if the triangles are similar. That is why we say that in similar triangle chapter, the triangles which are similar, they are drawn on scale factor. That means zoomed in, zoomed out of a particular 2D figure. So, and then we are given a zoomed in, zoomed out figure here. That means the sides are in scale factor. The sides are drawn in scale factor for the one that I'm outlining now. And this is how we get similar figures. Then we are given a formula for scale factor. What is scale factor? Scale factor is actually a ratio. Scale factor is equal to length in image divided by corresponding length in the object. That means image length divided by the actual length. Then following it, we are given a figure called rotation or a turn, then reflection or a flip, then translation or a slide. And then they have written something below. If a one shape can become another using resizing, then shapes are similar. Very obvious. So you resize, that means make an object small or big. Then that small object and the big object of the real object or compared to the real object, all of them are similar to each other. And then the last sentence writes, hence, 2 shapes are similar when one can become the other after a resize or a flip or a slide or a turn. So you turn it, you flip it, or you translate it, you get similar triangles. Now we see the first question, first MCQ based on the case study. The question reads, the A bit of the case study, a model of a boat is made on the scale of 1:4. So here we are given scale factor. Since scale factor is given, I'm writing the formula for scale factor. Formula for scale factor given in case study is length in object. So in the question they said scale is 1:4. So here scale is 1. Now it writes model is a 120 centimeter long. So the left side figure is the actual boat, the right side is the model, and they say length of the boat is a 120 centimeter. So the model of the boat length is 120 centimeter. And the question continues, the full size of a boat has a width of 60 centimeter. Now they are talking about the actual boat. Actual boat's width, I'm showing it on the diagram. Actual boat's width, and this is the length. So I'm showing you which is length and which is width of the boat. So here it is told that actual width of the boat is 60 centimeter. Appears 60 centimeter is a small number, but we'll follow the statement. If the actual width of the boat is 60 centimeter, the question is, what is the width of the boat in the scale model? So what is the width here in the scale model? This is what we have to find. Now let us come to the formula that we have written. Formula on scale factor is length in image by corresponding length in object. But they are asking width. So we can take this as width in image by corresponding width in object. And now this formula is 1/4 is equal to width in image. That means width of the model boat. That is already there, divided by corresponding width in the object, means actual width. Actual width is 60 centimeters. Now we can go for a simple cancellation of terms. 4 1s, 4 15s, and then we go for a cross multiplication, and hence we get width of the scale model of a boat. That means the model of the boat is 15 centimeter. And which option is this? This is the third option in the question. So this is the answer. Now let us answer the B bit of the case study. The question is, what will affect the similarity of any two polygons? In the case study, the polygon was a triangle. So we can imagine, or we can have a triangle in mind while answering this question. What will affect the similarity of two polygons? In the case study, they said if you rotate, or if you flip, or if you reflect, slide or translate, similar triangles remain similar. So that will not affect the similarity. So the first bit is they are flipped horizontally. If you flip horizontally, then also similarity is not affected. Second bit is they are dilated by similar scale factor. Dilated means in a way the word has come from dilution. That means you can zoom in, zoom out, make a triangle or a polygon big or small. Will the similarity be affected? Similarity will not be affected if you dilate by scale factor, because similar triangles, the corresponding sides are drawn based on scale factor. So on dilation, similarity will not be affected. Third bit is that they are translated down. If you translate the similar figure, translate up or down, similarity criteria will not change, because similarity perfectly depends upon the ratio of corresponding sides which grow based on scale factor. The last one, they are not a mirror image of one another. This is what will affect similarity of two polygons. The last bit is the answer. They are not a mirror image of one another. Similar triangles or similar polygons cannot be mirror images of one another. If two polygons or two triangles are mirror images of one another, they can be congruent. All congruent figures or congruent figures can be similar, but similar figures need not be congruent. So they are not the similar polygons. The polygons are not a mirror image of one another. If they are mirror images, they are no more similar, they are congruent. So the last option is the correct answer. Now the third question, if two similar triangles have scale factor A is to B, which statement regarding the triangles is true? So what is given to us is, we are given two similar triangles. So let me draw the triangles. So we have two similar triangles on the screen. Triangle ABC and triangle DEF. So these two triangles are similar, and they are similar on scale factor A is to B, means a ratio of corresponding sides are in the ratio A is to B. So all the three sides are in the ratio A is to B. So just to show only one part, I remove remaining. Yeah. So AB by DE is equal to BC by EF is equal to AC by DF is equal to A by B. So that is what is given to us. Given to us that triangle ABC is similar to triangle DEF. Along with that, the corresponding sides are however proportional. So corresponding sides are proportional to each other and they are equal to A by B. So they are drawn on the scale factor A is to B. Now the first one, ratio of their perimeters. If this is the situation that is given till now, we have to tell that then ratio of their perimeters are in the ratio 3A is to B. Okay, so whether it is true or false, for that I will prove it. So for the first bit, what can be done? Just see, for these two triangles, ratio of perimeters, we know that since if triangle ABC is similar to triangle DEF, then the ratio of perimeters of the two triangle, means perimeter of triangle ABC by perimeter of triangle DEF is equal to the ratio of corresponding sides. Ratio, if two triangles are similar, then ratio of areas is equal to ratio of squares of their corresponding sides. But if it is perimeter, it is equal to the ratio of corresponding sides. So ratio of perimeters of the two triangles is equal to A by B, not equal to 3A by B. So the first option is a wrong option. So first option is not possible. So now let's talk about the second option. Their altitudes have the ratio A is to B. So first in the diagram, let us draw altitude. So let AP be the altitude and DQ be the altitude. And now ratio of their altitudes we have to find. For that purpose, we have to first prove triangle ABP and DEQ similar. Now here, since angle B is equal to angle E, the triangles are similar, so corresponding angles are equal. And angle APB is equal to angle DQE. Both are 90 by construction. This implies that triangle ABP is similar to triangle DEQ by angle-angle similarity. And if two triangles are similar, then ratio of corresponding sides are proportional. Means AB by DE must be equal to AP, which is altitude, by DQ, which is also altitude. Corresponding sides of similar triangles are proportional. But AB by DE according to the question is A by B. So this implies AP by DQ. And what is AP by DQ? It is the ratio of the triangles or their altitudes. Ratio of their altitudes is equal to A by B. And here in the option, this is correct. So this is right. Now about the other two. The third one, they are writing medians and angle bisectors. Now keep in mind, if two triangles are similar, then ratio of their corresponding sides are always equal to the ratio of their corresponding altitudes, ratio of their corresponding medians, and ratio of their corresponding angle bisectors. Its meaning is ratio of corresponding altitudes are in the ratio A is to B. Ratio of their corresponding medians also is in the ratio A is to B. Ratio of their corresponding angle bisectors are also in the ratio A is to B. Let us answer the D bit of the case study. The question, the shadow of a stick 5 meters long is 2 meters. At the same time, this word is very important. At the same time means about the sun's altitude. At a particular time of the day, sun rays with respect to objects make equal angles with the horizon, means ground. So at the same time, the shadow of a tree 12.5 meters high is what we have to find. So here I do some basic labeling on the diagram. So tree is written here, so which I label as AB, and let name of the triangle be ABC. And stick, let me call it as DE, and name of the triangle is DEF. About these two, the tree is perpendicular to the ground, the stick is perpendicular to the ground. At the same time of the day means what? Angle C is equal to angle F. Its meaning is the triangle ABC and DEF are similar by angle similarity. So we can start the solution with the statement that since triangle ABC is similar to triangle DEF. And how are they similar? They are similar by angle similarity. The equal angles I have mentioned in the diagram. And because the triangles are similar, we can write the corresponding sides ratios are equal. So we can write AB divided by DE is equal to BC divided by EF, and that is equal to AC divided by DF, that we can avoid. That will not participate in the solution. So corresponding sides of similar triangles. Now in the question, AB is the height of the tree, that is mentioned 12.5 meters. DE is the length of the stick, that is 5 meters, that is also mentioned. Then shadow of tree is what we are supposed to find. So let it be X. EF is a shadow of the stick, that is 2 meters. So now let us work out these. Left side 12.5 by 5 is 2.5, and on cross multiplication 2 meters from the denominator right side on transposing comes to the left side numerator like this, and BC is X. So X is what? X is 5.0 or 5 meters. So length of shadow of tree. Length of shadow of tree is 5 meters. And which option is this? This is the last option, fourth option of the. Now let us answer the last bit, fifth bit or E bit of the case study. So given to us below, we are having left side a house and right side the attic of the house. So the attic of the attic floor, that means where I am putting outline right now. So attic floor is labeled as A, B, C, D, which is a square, and the vertex is a T. So the attic is in form of a square pyramid. And in the question they write that points E, F, G, H are the midpoints of the edges of the attic, and every edge is 12 meter. Every edge is 12 meter. With this information, we have to tell what is the question writes here continuation. What is length of EF, where EF is one of the horizontal edges of the block. So let me draw only the face where EF exists. So the attic, which is a square pyramid, base is a square. One of the faces consists of T, A, B, and the midpoint of AT and TB is EF, and we have to tell length of EF, where length of AB is 12 meters. And also in the question, E is midpoint of AT and F is midpoint of TB. So how to find EF? So here by midpoint theorem, EF is the line joining the midpoints of two sides of the triangle. So the line joining the midpoints of two sides of a triangle is a parallel to the third side and is a half of a third side. So by midpoint theorem, since E and F are midpoints, we can write EF is a parallel to AB and EF is a half of AB. But in the question, AB is 12 meters. So this will guide us to find length of EF. EF is a half of 12, that is 6 meters. And which option is this? This is the third option of the question.